Hello, my name is Stanislav Danylenko and I want to present you parametric configuration approach of a multidimensional content-based image retrieval model did by me, Kyrylo, Smelyakov, Anastasiya, Chupryna from Kharkiv National University of Radio Electronics and Victoria Vysotska from Lviv Polytechnic National University. The parametric configuration is a method of defining a system, model or component by using parameters that determine its structure, behavior or appearance. It's commonly used in a wide range of services like video surveillance, emergency system, antivirus software and others. So in content-based image retrieval, model parameters can significantly affect the search speed or result quality. This may have negative consequences in critical domains such as medical diagnostics or emergency recognition systems. Therefore, an important research problem arises, that is studying the parameters of content-based image retrieval systems, their configurability, their impact on search outcomes. And the objective of this study is to explore this problem using the multidimensional cube MDC model and by introducing experimental approach of the parametric configuration. The tasks are define a parameter selecting approach, experimentally evaluate its effectiveness and draw conclusions specific to the given model. Here you can see the example of the parameters of different models from different groups. For example, it's for multidimensional trees, graph-based, hashing-based, inverted index, inverted multi-index based models, and our use case is MDC. Here you can see the main parameters of the MDC is the total number of images in the storage and its expected search page size of our search system. And as you can see, the other parameters are dependent. Parameter number of cells is calculated by the number of segments and the number of dimensions, and also the real search page calculated using these parameters, and it should be as close as possible to the expected search page size. So this is how these parameters are used. As you can see, the parameter D, count of dimensions, is used to specify the dimensionality of the aggregated feature vector, and the parameter S is used to splitting the possible values range of the one of the value of the descriptor to the specific segments, and then this value fall to the specific segment, and the initial vector, aggregated vector, are replaced by the vector of indices which describe a location of this vector in a bounded multidimensional feature space, as you can see in the figure 2. And also here you can see in the figure 3 the example of the wave search. So firstly, the search are executed in the determined cell of the multidimensional cube, determined for the searched image calculated by its descriptor, and then if this search in this cell is not successful, we execute search in the nearest cells for this cell with length 1, step 1, and then if it's not successful, then we continue to increase or decrease the indices to difference 1, 2, 3, and execute waves near this initial target cell. Here is example of the optimization the boundaries of these segments. Firstly, you can see these dimensions are divided evenly, but the count of the values are not equals. Then we move the boundaries up and down, and in results we can see the dimensions are divided not evenly, but the count are even. So here is an example of the parametric configuration for the MDC. Here you can see these main parameters D and S, also the calculated value of the number of cells and the estimated number of descriptor per cell, and we must choose the values from this last column. So this is done programmatically, so the expert only need to choose the value from this column, as I said. And for example, for these experiments we choose two configurations, as you can see here, and also another critical parameters is selected is database management system, because MDC is located in the database. So for another models you can see the main parameters and also create the such table, or can be in different form, and choose different combination and examine it, do simple experiment and choose the proper parameters, maybe find some dependencies between these parameters and your data, and so on. So this is the first step, is to database management system comparisons. Here you can see the most popular nowadays database management systems, and the best of them was Postgres. And as you can see, the build time for the configuration 2 is lower than for configuration 1. This is this line. But if we see on the results of this optimization, it's really good for the configuration 1 and for configuration 2. So we can see the small impact of this configuration on this step. And let's move on. This is our main experiment. It's search comparison for these two configurations, and also for the brute force search. The 100,000 descriptors was uploaded to the MDC, and also for 100 randomly selected images. Two modification were created, and also the descriptors for these modifications also were added to the MDC, and the experiment was executed for searching original images left side and the original and modified images by the main metrics like labor intensity, count of descriptors that were examined during the search, the quality measure from 0 to 1, count of waves executed during the search, percentage of all descriptors during the search, and search time. As you can see, for the first case, the best configuration is configuration 1 for all metrics, but for the configuration 2 we can see similar picture, but except this max values line and this search time, it's much bigger than from the brute force, and we need to investigate this issue and probably find the root cause why we have this value here. And we did it, and we found the dependency between MDC parameters and the wave search that wasn't described in any documentation of this model. So it was added after this investigation by this formula. So the number of descriptors checked during the single search wave was introduced by this parametric configuration and experiments, simple experiments. And as you can see, in our second configuration we really have this value is equals to the total number of descriptors in the dataset, but because brute force search is faster, because it executes only one query to the DB, it's faster because MDC executes several queries and it's more time consuming. So we can say that parametric configuration is strong for the content-based image retrieval model, and you can use it to test and choose the best content-based image retrieval model for the use case. It's the simplified examples as we did, and you can choose it and spend less time for configuring, for finding some dependencies and so on. And thank you for your attention.